Okay. So today we're going to talk about the washer method. Okay? And it's, remember yesterday so it's after the notes from yesterday. For somehow they're out of order in the notebook. Sorry. You can deal with it. Okay. Actually, before we do washers, we're going to do a little bit of other rotation around a line that's not on the x-axis, okay? So we've got to find the volume generated by revolving the region bounded by the graphs of the equations, and now we're revolving around the line y equals 1 instead of an axis. So the difference between a disk and a washer is when you're doing a disk, the function touches your axis of rotation, okay? When we get into washers in a couple examples, we do not touch our axis of rotation, which gives us 2 circles more rather than 1. So this one, if I drew the picture of it, okay, maybe if the pen will let me draw. Let's see. It doesn't like me right now. Oh, what's that? Oh, it came back. There it is. Okay, so if I were to draw this picture, what's that a picture of? A parabola. Is it right side up or upside down? It's upside down, and it's up at 2, right? So we know it's going like this. Okay, actually I shouldn't have drawn it even that much. Okay, I'm not even going to draw that much of it. I'm going to do it in a different color. So and then also we have this line here, which is a horizontal line at 1. I'm going to draw that line in first, actually, and then draw my parabola. So what I am doing is I'm taking that little region, but I am revolving around this second line. Do you see that? We're revolving around that instead of the axis. All right, so this is a little bit weird. So remember when we did area under a curve, and we said in order to get rid of this gap, because the only thing I can do when I can integrate is it will get me the area between this and the axis. That's what an integral will do. It won't take care of that gap, which means I have to subtract my functions, okay? So the radius length on this, or the r, would be the top function. What's my top function right now?
F.
The f, 2 minus x squared. What's the bottom function? 1, so minus 1. And it seems weird that a function is just a number, but it is. In this case, it's a line. Could I simplify that before I deal with it? Yeah, so what's the real radius? Excuse me, what's the real radius? 1 minus x squared, right? All right, now let's talk volume just like we did yesterday. Again, it's around that axis of rotation, okay? Let's see. We have to go volume. What's it start with? Pi. Uh-oh, they didn't give us limits. We'll go back and do limits in a second, okay? What's my function that I rewrote? What's my new radius? 1 minus x squared. What are you supposed to do to it? Square it. Dx. All right. How do you think I'm going to get these guys right here?
Isn't it 1 to this color or no?
We're going to set them equal to each other, right? That's how we get, if we don't know what they are, with points of intersection come from setting them equal to each other. All right, so we've got negative x squared equals what?
No,
Negative 1. Negatives are going to go away, so what's x squared equal to? Plus or minus 1, right? Take the square root of both sides. If you need me to write it on there, I can. Okay. All right. There are 2 ways we could do this. Actually, there really aren't. I could try to use substitution. That's not going to work. Okay? Because I don't have an x sitting there, right? So I'm going to have to do what with this? Foil it. Okay, so I'm going to do my scratch work over here. 1 minus x. You can use the box if you like the box. That's fine. I'm not opposed to a box. All right, 1 times 1 is? 1, what are you going to get in the center? What's the middle, guys?
It's 2x to, 2x to the
Squared. Okay, and then what's the final term? X to the what? 4th. Good. Dx. Don't let the algebra weigh you down, okay? Usually that's the calculus part isn't the problem, right? It's always the algebra. All right, what am I going to do now? Integrate. So it's not anything different than what we've been doing for months, okay? It's slightly new beginning process. So what is what I integrate? 1, what do we get?
X minus 2/3 x to the third.
X minus
2/3
2/3 x
x to the third.
to the third. Everybody okay with that?
Plus
X to the 5th over 5 from -1 to 1. Okay. All right. We got to plug in. Notice we don't have 0 on the bottom right now, so it's a little different than yesterday. We have more work to do, more fractions. All right. Put in a 1. We get 1 minus 2/3 plus 1/5 minus. Be careful with your signs. -1. What's -1 cubed? But so that's going to make it positive 2/3. -1 to the 5th is, so -1/5. What are we going to do with that negative sign? Which I'm going to do just all in one shot, right? So I'm going to change all my signs from distributing this. Okay. I'm going to combine my like terms together, then I'll deal with my fractions. So what's 1 plus 1? 2. Minus 4/3 plus 2/5. Now, technically on the AP test, if it was free response, you don't even have to do this. You could leave it right there and they'll take that answer. Okay? But if it comes up as multiple choice, we have to simplify, right? So, what should our common denominator be? 15? Okay, let me get back there. All right, so we've got, let's see, 30/15 minus what in 15ths? 10? Don't I have to multiply it by 5? 20/15, okay, plus 6/15. Okay, so what do we end up with for our final answer there? Good, 16/15. And again, you have to be able, practicing the fractions isn't a bad thing. More likely to be on the non-calculator than the calculator with this. Okay? All right, we good with 1? No. What's wrong? How did I FOIL this? Or this thing here? 1 times 1 is 1. 1 times -x squared is -x squared. I have 2 of those in the middle. X squared times x squared is x to the 4th. Because if I tried to use a u substitution, my u would have been 1 minus x squared, so du is -2x dx, and there's no x. Right, so I can't use u substitution this time. Had that other x been there, u substitution would have been nicer. Okay? All right, let's keep going. We may want to make sure we get through this today. We're going to find the volume generated by revolving the region bounded by the graphs equation about the line y equals 4. Notice that's our second function, isn't it? And then this line right here. So that's a picture of a cubic. Let's draw a picture of a cubic. A cubic typically comes down here and then kind of loops up here. We only need that top part because it said that that's a boundary. And then we also need the line y equals 4. Yes, it's, no, it's not actually. We're revolving around that. Let me make sure I do it right here. All right, let's talk about our radius. Okay, so we have to do the top function minus the bottom function. What is the top function right now?
4.
It is 4. What's the bottom function?
1/2 x to the 3rd.
So that is our radius, our new function that we'd put in our formula, right? It's not 0 to 4. That would be the y's, wouldn't it?
No, say because x is already 0, so it's 0 to something, right?
It's 0 to something. It's 0 to whatever that x value is right there, right? How do I get that x value? Set them equal to each other. So let's do that next. Let's get all the parts. Okay. All right, when I move the 2 over, how do I do that? Multiply, what do I get? 8, and then cubed root of x is 2. So it's 0 to 2. All right, let's do volume. What What does volume start with?
Pi.
Pi, or rotational volume starts with pi. We're going to go from 0 to 2. Okay. I'm going to put my radius in there. 4 minus, this is not fun, is it? X cubed. And what am I going to do to that? Square it. And then I'm going to go dx. Okay. All right, we're going to have to FOIL it again. It's going to be messy. You're going to deal with the fractions, and it's going to be okay. Fractions are our friends.
I remember you saying that, though.
Huh?
I remember you saying that.
Fractions are our friends, not food. Right? Fish are our friends, not food. Finding Nemo. All right, 4 times 4 is? 16.
Wow, Robert.
Oh, it's fine. He dropped a notebook. It's not a big deal. 4 times negative 1/2 is? What? Negative 2, and how many of those am I going to have? 2 of them. So I really got negative 4x cubed in the middle. Negative 1/2 times negative 1/2 is? 1/4 x to the, not the 9th, but the 6th dx. No, you add exponents. When you're multiplying, you add the exponents. When you have power to a power, you multiply the exponents. Again, little algebra steps that kill us, right? Ruin the whole problem. Okay, what do we get with the, when I integrate? 16x minus x to the 4th. What happened to the 4? Cancels. Good. All right, and then we get, what with this one?
128 x to the 7th.
Okay, so we get x to the 7th, divide by 7, so we multiply 4 times 7, that gives us 28. And again, do you see why? We've got so many lines, and they're complicated. The more of that little tiny stuff we can do in our heads, the better. Okay? If you... What?
Why did we do that?
We just do. Okay. We're going to go from 0 to 2. I don't know why I wrote a dx. Typo. Get rid of that. Okay, is the 0 going to matter? No. Okay, so let's put in the 2. What is 16 times 2? 32. 2 to the 4th? All right. It's 16, not 32. That's 2 to the 5th. Don't listen to CJ.
What? Look
All
at
right.
everything above that.
128. All right, what's 2 to the 7th?
If 2 to the 5th is 32, that means 64 and then 128.
Yep. Okay. Let's see. 32 minus 16 is 16, right? What's this fraction reduced to?
Ooh, let's use a calculator now.
You could. And you know what? At this point, you're doing homework, right? You have the calculator in front of you. Could you use the calculator to get that in a fractional state?
32 sevenths.
The whole. This is 32 sevenths.
Yeah.
Let me redo. Let me just.
Why are you gonna run it there?
Laziness. Okay, so 32 sevenths. What is 16 in sevenths?
7 times 16 is like 80 something. Just kidding, 12.
Plus 32 sevenths.
Which is gonna be 144.
You all okay with CJ's work?
And then 7 divided by 144.
You're not gonna. You don't want a decimal point. You will not see these as decimal point answers. With a pi tacked onto the end, never. Okay? Alright. Here's what we're going to do. We're going to set up the next one. I'm probably not going to integrate it. Maybe. Let me see how far we get with this one. Because I want to make sure we get to our washers before we leave.
Wait, why are we revolving around x minus x equals 6?
What's wrong?
We're revolving around x equals 6.
Yeah, I know.
X equals 0, y equals 0, and y equals 4.
You'll see why. Okay? Just be patient. So now we're revolving around a vertical line. Okay? So let's draw the picture, and so we make sure we understand the picture first. What's that a picture of? A line. What's the y-intercept on the line?
6 over 1.
6. So I'm up here at 6. And what's my slope?
Negative 1 over
Down 1 over 1, which means that if I went down 1 over 1 enough times, wouldn't I end up at 6 down here? You would. Okay. Then, but it says that we're taking that line, I'm going to draw it in a different color, and we are revolving around the vertical line y equals 6. We're revolving around this. Okay, oh, and there's a lot of weirdness here. Okay. So we're revolving around that right there, but the thing is we're taking this region right here and revolving it. So when I revolve that, think about what happens. We're revolving that kind of a picture. It's like you get a rectangular prism with a cone cut out of it.
It's a cup.
Okay, kind of a cup. It's some weird modern restaurant, right? Okay. So what we have to do is we have to take some stuff away. So we have to figure out, first of all, we need to be in terms of y because we're rotating in a y direction, right? So we need to solve this for x. So what am I going to do to solve this for x? We're going to subtract the 6, so y minus 6 equals negative x, and then what do I have to do? Divide by negative 1, so I really have, 6 minus y equals x. I just reversed the order. Yes, CJ?
Isn't the y equals 0, y equals 4, and telling you how much of that little triangle is shaded?
Yes. That's going to be your limits. Do you see now why there's 0 and 4? It's the limits. Okay. So we are now going to, do kind of the same thing we did before. We're going to do and this gets us more into the washers, okay? What's wrong?
That's also like the y equal 4, right?
Okay, so I'm going to talk about that right now, okay? So these, remember, we're going in the y direction, right? Which means I need y limits. So my y is starting at 0 and ending at 4. So I'm going to draw another line in here. It isn't a picture, actually I'm going to draw it dashed. That's where we're going to stop. So do you see that we're really only doing this trapezoid here around it? Okay.
You gotta redraw your cut down.
Yeah, I'm not going to. All right, so let's start setting up our volume a little bit. We at least could get the pi. We know that, right? And then what are my limits going to be? Guess what? AP test, that's usually a point to do that. If you did nothing else on the problem, could you do that? Okay.
Point on every problem. Like, is that a good score?
On the 9 points on each free response problem, if you can pick up 3 to 4 points, you're going to pass on each of the 6. Okay? All right. You got to do okay on the multiple choice too, but on the free response, if you can pick up 3 to 4 points a problem, you're looking pretty good. Okay? At least getting a 3. If you want a 5, you got to pick up more than that. Okay? All right. So, now we've got to deal with our functions, and it's a little bit weird on this one. Okay? We're going to treat them as 2 separate circles. This is more washer-like. Okay? And you're going to see washers here in just a second. What's this outer function here? What's my outermost function? What's that line? 6. Okay? And I'm not going to do, because of where the gap is, see how how it's not the function? This purple line is not touching the axis of rotation. Do we see that? Yes? Okay, so that means I have to do 2 separate circles. So I'm going to do 6 squared minus, what's my other function in terms of y? 6 minus y squared. Oh, never mind. I screwed that up. I don't know what's... I'm not reading my notes right. Okay. Let's do our radius just like we were doing it before. I'm doing it wrong. Sorry. All right. So my radius, I knew it had to be up in front of the washer stuff for a reason. So if I'm talking about my radius, what's my outermost function? 6. Okay, what's my inner function? My more to the left function in terms of y? 6 minus y. What's going to happen with that negative? It's going to distribute, right? So what is the radius that we're looking at? Y. Okay, now this is where it gets weird. Okay, so that's the radius we're looking at overall. Okay, but I still have this funky gap where the function is not touching the green line. Okay, and it'll make more sense when we do a couple more washers. So my outer function is still the 6. And my inner function, and we're doing this separately because of the washer, is this y. dy. And I know I didn't explain that very well. We're going to we're going to go get through it and go to the, and once we look at the washer, it's going to make a little more sense. Okay? All right. So when we integrate 6 squared, which is 36, what do we end up with? 36y minus y to the third over 3 from 0 to 4. All right, 0 is not going to matter. What's 36 times 4?
144. Don't trust that. Wait. 120 and then 24. Oh, yeah, Mike.
Okay, it ended in the right number. That's how I got it. All right, what's 4 cubed?
Yeah.
64. All right, in interest of time, I had written down that it was 368 thirds pi when I did the actual arithmetic there. All right, you got to write that down. Let's finally get to these washers. And that's basically the formula we used on that last problem. That last problem was weird. Out of all the ones we do, washers are probably the worst. Okay, out of the 3 that we do. Downside of tomorrow's, there's a whole bunch of area formulas you need to know. We'll have to get that sign out.
So was a CD a washer?
Yes. I'm impressed you know what a CD is in this day and age. You guys have lived through that. My kids don't know.
What are you talking about?
I guess they, like, my kids wouldn't know it as a CD. They'd say DVD, right?
I have a disc jockey. What are you talking about?
My first boombox had a CD player in it. It was one of the first ones.
I used to go to school when we had a Walkman.
When I first started teaching, instead of taking away iPods, Miss Salmon, because Miss Salmon subbed for me way back then, she took away the CD Walkman.
Oh my god. So I was
Yeah,
in practice
that was my
here
first year.
And this girl had a legit flip phone. You know, like back in like 2005. There's that cool flip phone that flips sideways and forward.
Oh, yeah.
Oh.
She had one of those.
Did you ask her if we could recycle it for her?
I might ask her that now, but you know, practice do this.
No,
recycling.
don't do that.
It's gonna hurt her feelings a little bit.
All right, so
Just a little bit.
a washer is basically a disc with a hole, okay? The problem is that now we have an outer circle and an inner circle. So how many radii do I have? 2, right? I've got that big one, and then we've got this little one, and we have to subtract this whole part out. So that's where this formula comes in. You do the outer function squared minus the inner function squared, okay? That's what we were doing on that last problem, even though it was weird. That's what a picture looks like. So now you've got that thing that goes around when you take the dog to the vet, right? The cone that goes around their head. Okay. All right. I don't know. We don't have a dog, so we don't have to go to the vet. So, or a cat, or anything else that breathes, other than my children. Okay, we're gonna find the volume of the solid form by revolving the region about the x-axis. Okay, and again, you know it's a washer because it doesn't touch the axis of rotation. The function doesn't physically touch it. Okay, that's a square root function, which hopefully we know looks like this. That's a parabola, which looks like this. So what we're doing is we're taking this little guy right here, and I'm rotating him about that. So do you see how neither function touches our axis of rotation? That's a washer. That means I have to do function squared minus function squared. Okay, so let's talk volume. What does a revolving volume start with? Pi, always. We'll deal with limits in a minute. Okay. What is my function that is on the top?
It's going to be that one right there. This one like this.
Which one is it?
I think it's the square root.
The square root function. And we have to do what to it? So the difference is today we are squaring them individually with the washers. Okay, and then my bottom function is x squared dx. I should probably have a whole big parentheses around it, but that's just so many parentheses. I'm not going to do that. How am I going to get where they cross? set them equal to each other. So there's some very basic steps that we've been doing over and over, okay? You got to get used to that. All right, how do we undo the square root? Square it. So we get x equals, x to the 4th. So 0 equals x to the 4th minus x, right? What can I factor out? X. The pen is writing really funky right now. It's not 33. Oh, and I didn't get the eraser. The pen's battery is probably dying. Okay. Oh, minus 1, right? So what are my two x values? 0 and 1, right? So those are my limits, 0 to 1. Okay. So pi, what happens with the square and the square root? Cancel. So when I integrate that, what do we end up with? Okay. That's really x to the 4th. So when I integrate x to the 4th, I get x to the 0 to 1. 0 is not going to matter. 1 is. So 1/2 minus 1/5. All right. And if we did the actual arithmetic on that, final answer would be, I want to get to the last example, so we make sure you have all the setups, at least 3/10 pi. Okay. Let's go one more here. I want to make sure you see this setup. Okay, the good news is it says y-axis. We're already in terms of y, so they've taken care of that step for us. The downside is we have to graph it to understand it, so I'm going to have to put it back in terms of x. So what am I going to do to move this over to the other side? The reason I'm doing that is to graph it. So y equals x minus 2. What's my y-intercept? 2. Or actually not 2, but negative 2. And what's my slope that I'm going to count? So really I start there, up 1 over 2, up 1. And notice, I'm not even going to start graphing it till I hit that axis, because I'm revolving. Oh, because of this other line I'm revolving around. Okay, so let me go up a couple more. Okay, so we would be, maybe if I can get the pen to draw. All right, so we're like that. And again, I'm not drawing the whole thing on purpose. We also have the line y equals 3, which is up at the top here. So that's kind of the cutoff, right? And we also have this vertical line x equals 2. Do you see why I stopped drawing there? So what we're doing is we're taking this triangle here, and we're revolving it around the x-axis or the y-axis. So is this region that we're revolving directly touching the axis of revolution? Yes or no? No. So that means that we have a washer. Okay? So let's see what we can do. Oh, this one's really weird. Oh no, it's not that weird. Okay, what is my rightmost function? I can't do left and right. What's my leftmost function? Which is y plus 2. What are we supposed to do to it? Square it. Minus, what's my leftmost function? No, because we're doing this in terms of y. We only did this to graph. We still need to use our y's because we got a vertical rotation. Okay? All right, so what's my other function? The 2 squared. We're dy. What did I forget in front? Pi. I got 2 into making sure I was drawing everything. The good news is we're going in the y direction, right? What are the limits? 0 to what? Good. 0 to, so I didn't have to think about that or calculate that. All right, let's do some foiling. So we've got y minus 2 times y minus 2. What's that FOIL into?
Y squared.
Plus what? Oh, not plus. Minus what? Minus 4y plus 4. Minus the 4 from that 2 squared, right? Did everybody see the 2? What?
Yeah, y plus 2 squared. You messed up. So it's plus 4y. Right in the foiling.
Oh, you're right. I had it right the first time, didn't I? Okay, what happens with these 4's at the end? Okay, I'm not going to rewrite the line to make it pretty, just to integrate it. What is y squared when we integrate? Y cubed over 3 plus...
It's 2y.
2y squared? Okay, because it's y squared over 2, and then we divide the 2 into the 4. All right, and then from 0 to 3?
0 doesn't matter, so 3 to the third is 27 divided by 3, which is 9.
We okay with that?
And then plus 9 times 18.
Everybody okay with the 18? Okay.
Plus.
Plus, thank you. I was going to say we don't get negative. What am I doing wrong? Okay, and we get 9 plus 18 is? Very rarely does our answer come out negative with volume. It wouldn't make sense to try to build a negative shape, right? A negative cup has